This project demonstrates a production-ready multi-cluster GitOps platform designed to manage and deploy microservices across multiple Kubernetes clusters and environments in a consistent, automated, and scalable way. At its core, the platform uses ArgoCD as the control plane to continuously monitor a Git repository and ensure that the actual state of the system always matches the design state defined in code. By combining ApplicationSet, the system can automatically generate and manage deployment for multiple services environments and clusters without manual configuration. The project follows a clean and extensible structure using Kustomize, where each service is defined with a reusable base configuration and environment-specific overlay. This approach makes it easy to customize deployment, such as replicate, namespace, and image version, while maintaining consistencies across environments. Overall, this project provides a complete example of how to build a modern DevOps platform with multi-cluster deployment management, GitOps-based automation, environment-specific configuration, progressive delivery with Canary releases, self-healing and scalable infrastructure. It serves as a solid foundation for real-world systems and can be extended with enterprise features such as secret management, monitoring, ingress, and infrastructure provisioning. CI/CD flow explanation. This process flows a fully automated CI/CD pipeline combined with the GitOps principle, ensuring the every change is traceable, consistent, and safely deployed across multiple environments. The process begins when a developer puts code to the repository. This action triggers GitHub Actions, which serves as the CI pipeline. It automatically builds a new Docker image based on the latest code and prepares it for deployment. Once the image is built, it is pushed to the Docker registry. This step ensures that the application interface is stored in a centralized and version location, making it accessible for deployment across different clusters. After that, the pipeline updates the Kustomize YAML file in the GitOps repository with the new image tag. This is a critical step because in a GitOps model, Git is the single source of truth. Any deployment change must be reflected in the repository rather than applied directly to the cluster. The update configuration is then pushed back to the GitOps repository. At this point, ArgoCD continuously monitors the repository and detects that a change has occurred. Once the change is detected, ArgoCD automatically synchronizes the new state to the Kubernetes cluster, thanks to the use of ApplicationSet. This deployment is applied consistently across multiple clusters and environments without manual intervention. Instead of deploying the new version immediately to all users, Argo Rollouts handle the release process using a Canary strategy. The new version is gradually introduced by shifting traffic in control steps. This approach minimizes risk, allows real-time validation, and ensures that any issue can be detected early before full rollout. Overall, this flow creates a seamless pipeline from code commit to production deployment with strong guarantees around automation, consistency, and reliability. Complete architecture explanation. The architecture is designed around a centralized management model with decentralized execution. At the top level, the GitHub repository stores all application configuration and deployment definition. This repository acts as the single source of truth for the entire system. In the center, ArgoCD runs in a dedicated management cluster. Its responsibility is to continuously watch the Git repository and orchestrate deployment across all target clusters. Below the control plane are multiple Kubernetes clusters, typically separate by environment, development, staging, and production. Each cluster operates independently but follows the same deployment model defined in Git. When a change occurs, ArgoCD uses ApplicationSet to determine which applications should be deployed to which cluster. It then applies the configuration accordingly, ensuring that each environment receives the correct version and setting. Within each cluster, Argo Rollouts manage how applications are deployed instead of traditional deployment. It enables advanced strategy like Canary releases, allowing gradual traffic shifting and safer updates. This architecture provides several key benefits: centralized control with ArgoCD, consistent deployment across multiple clusters, clear separation of environment, safer releases with progressive delivery, easy scalability as new services or clusters are added. In summary, the system combines GitOps, multi-cluster orchestration, and progressive delivery into a unified platform that is both robust and production ready. Demo flow. This project is designed to guide you through building a real-world production-style DevOps platform using Kubernetes, GitOps, and modern CI/CD practice. The goal is not only to deploy applications, but to create a system that is scalable, automated, and easy to manage across multiple environments. Part 1. Project Goal. At a high level, this project helps you build a complete system with both control plane and workload cluster. You will start by creating one central cluster that runs ArgoCD, which acts as the brain of the system. Then you will set up multiple workload clusters such as deployment, staging, and production. This cluster will run your actual application. On top of that, you will implement multi-cluster deployment using ApplicationSet, progressive delivery using Argo Rollouts, a CI/CD pipeline that automatically updates the GitHub repository. By the end, you will have a fully automated deployment system where code change can safely house from deployment to production. Part 2. Environment Setup. Before building the system, you need to prepare your local environment with essential tools. These include Docker for containerization, Kubernetes control for interacting with Kubernetes, K3D for running lightweight cluster, the ArgoCD CLI for managing deployment, and Git for version control. After installing, it is important to verify that K3D is working correctly. This ensures you can create and manage local Kubernetes cluster without issue. Part 3. Creating multi-cluster with K3D. In this step, you will create multiple Kubernetes clusters locally using K3D. Each cluster represents a different environment, such as that, staging, and production. Each cluster is created with a separate API port and configured with a TSL send to allow secure communication. You also need to update the Kubernetes configuration so that each cluster can be accessed correctly. To manage this work, you first retry your merging IP address. Then you use the IP when creating cluster to avoid certified issue. Once zone cluster are created, You verify them using get contact and node command. This confirms that your multi-cluster environment is ready. Part 4. Creating the control plan. Instead of installing ArgoCD on one of the workload cluster, this process follows a best practice creating a dedicated management cluster. This cluster is responsible only for controlling deployment, not running application. After creating the management cluster, you install ArgoCD into a separated namespace. Then you expose the ArgoCD UI using port forwarding and logging using the CLI. At this point, ArgoCD becomes the central control that will monitor your Git repository and manage deployment across all cluster. Part 5. Adding cluster to ArgoCD. Once ArgoCD is running, the next step is to connect it to your workload cluster. Using the ArgoCD CLI, you register each cluster. This allows ArgoCD to deploy applications to them remotely. After adding the cluster, you verify the connection. This step is critical because it ensures that your control plan can communicate with all target environment. Part 6. Installing Argo Rollouts. To enable advanced deployment strategy, you install Argo Rollouts on each workload cluster. This must be done separately for that staging and production cluster. The reason is simple. Rollout logic run inside its cluster where the applications are deployed. One install Argo Rollout allows you to perform Canary deployments, where traffic is gradually shipped from the old version to the new version. This reduces risk and improves reliability. Part 7. Repository preparation. The system is organized into multiple Git repositories. There is one central GitOps platform repository which contains on Kubernetes configuration and deployment definition. This repository acts as the single source of truth. In addition, these are separate repositories for each service, such as auth, product, and other. Each service repository includes a CI/CD pipeline and requires requests such as Docker Kubernetes and a GitOps asset token. This token allows the pipeline to update the GitOps repository automatically after building a new image. This separation of concerns makes the system modular and easier to scale. Part A. Deployment. Finally, you deploy the system. You start by applying the ApplicationSet configuration from the GitOps repository to the management cluster. This tells ArgoCD how to generate and manage application across cluster. Then you switch to a service repository and push code. This triggers the CI/CD pipeline, which builds a Docker image, push it to registry and update the GitOps repository. ArgoCD detects the trend and automatically deploy the new version to the appropriate cluster. Argo Rollouts then handle the release using a Canary strategy. Finally, result. By completing this project, you will have built a fully automated multi-cluster GitOps platform. The system supports centralized control with ArgoCD, multi-environment deployments, automated CI/CD pipeline, safer and gradual releases with Canary strategy. More importantly, This is not just a demo. It reflects how modern enterprise systems are designed and operated, making it a strong foundation for real-world application and career growth in DevOps and cloud architecture.